Main factors that affect a reaction rate: concentration, pressure, temperature, and surface area. Concentration is the measure of amount or number of particles in a given volume. Concentration can be increased by increasing the number of particles and keeping the volume constant, or decreasing the volume and keeping the number of particles constant. For example, let's take solution B, which is hydrochloric acid, and solid A, which is marble chips. As we react the two substances, you can see that the very few H3O plus ions react with the marble chips. This causes a dilute solution, a slow reaction, hence a low reaction rate. In contrast, in a more concentrated solution of hydrochloric acid, there are a greater number of H3O plus ions that react with the marble chip particles, hence providing a faster reaction and a higher reaction rate. We know that gases can be compressed, whereas solids and liquids cannot. Therefore, pressure only affects the reaction rate of gases. For example, let's say if we have gas A, gas B reacting to form gas C. Gas A and gas B to react, they must collide with a sufficient amount of energy. Collisions between particles to form a reactant are known as fruitful collisions. Therefore, rate of reaction equals the number of fruitful collisions. If the pressure of this reaction is increased, the volume will decrease and the concentration will increase, hence increasing the rate of reaction. Particles require a sufficient amount of energy to react. This is known as activation energy for successful collisions. Increase in temperature allows an increase in the average kinetic energy of particles, which allows more particles to react, resulting in more successful collisions, hence increasing the rate of reaction. Referring back to the example of hydrochloric solution and a marble chip, the H3O plus ions from the hydrochloric acid could only react with the surface of the marble chip. Now, if we break this marble chip into two parts, the total mass would remain the same, whereas the surface area has increased, allowing the H3O plus ions to react with more of the marble chips in a given period of time. Hence, increasing the surface area allows an increase in reaction rate. Rusting is an example of a slow reaction. Rusting occurs when iron is exposed to oxygen and water vapors. The reaction rate of rusting is typically higher in areas with humidity because of the greater concentration in moisture. As you saw in the beginning of the video, an explosive is an example of a fast reaction. The high rate of energy collisions between particles produce enormous amounts of heat, pressure, and light. A refrigerator in your household is an example of a device that controls a reaction rate. Low temperatures allows slow movements of particles, hence decreasing the reaction rate and allowing your food to remain fresh for a longer period of time. Well, that's all folks. Hope you enjoyed.